Hey everybody, welcome back into another fun and exciting Algebra 2 class. Today we are going to be beginning Chapter 2 in our books, and that's on page 58 if you have a book, if you're following along, that's page 58. And what we're going to be talking about today is how to solve linear equations. A linear equation, sometimes that word, we get confused with that. But I want you to think about the first part of the word. Okay, I'll write it up here on the board. You can see it. Linear. Okay, let's look at the first part of the word. Okay, let's just kind of reduce that down to the first part, and we'll just even get rid of the second part. What is the first part of the word? Line. These are line equations. Well, what does that mean? That means that these equations are going to form lines. And a little bit later in subsequent chapters, we're going to be talking about what that looks like. How do we actually draw the line? If you remember back in Algebra 1, we did some of this. We actually drew lines. We used it in graphing and things like that. So we're going to get back to that. We're going to actually do a little bit more complex linear equations and quadratic equations and all kinds of other things that will form parabolas and different things. But for now, we need to, in this lesson, talk about how to solve linear equations. What are we going to do with them? How are we going to solve them? Okay. So if you will, go ahead and, like I said, open up your book to page 58. I want to show you something down here that I already wrote out. You can look down there at the screen and see what it is. It's called Steps to Solve Linear Equations. Steps to Solve Linear Equations. Now, you're not going to find these in the book. You'll find a list in the book. It'll be similar. You might see some of the same things there. But number one, I always say, I try to simplify this out, and I say, do what you can do. Do what you can do. In other words, if you see something that you can solve, if you see an addition that is like numbers, if you see terms that you think that you can combine, if you see anything that you can do. Now, I'm talking about with like terms. And so maybe we can specify that. We can put like terms. Okay? So we're looking for things that are like terms. We're going to combine, we're going to distribute, we're going to do what we can do with like terms. Now, there comes a point at which you can't do anything else. In other words, everything on this side of the equation is all solved, and everything on this side of the equation is all solved. We can't go any further. And so when we get to that point, we have to start isolating. To isolate means to put by itself the variable. We want to get the variable all by itself. And the first way to do that, notice, is with addition and subtraction. Now, this may sound contrary to the rules of operation, the order of operation. And it sounds contrary because it is contrary. We do addition and subtraction last. What's the easiest way for me to tell you this? Think about it like this. When you're solving an equation, you're kind of working the equation backwards. You're kind of starting at the end and working it backwards. And so that's why we do the addition and subtraction first, because you're going in backwards order of operation, kind of. You're still going to want to distribute first, things like that. But when it comes to the multiplication and the addition, you're going to do the addition first here in the equations. So it's a little different. The next thing, number 3, after you do that, then you would go back and you would continue to isolate the variable by doing multiplication and division. So that sometimes the variable still is not isolated after you do the addition and subtraction, and you need to continue that by doing multiplication and division to get the x by itself, to get the variable by itself. Then the next thing that you would want to do is you would want to check your solution. Never should you, on an algebra test, at least one that's with equations, never should you wonder, I wonder if I got that right. You should always be confident in your answer. You should always tell me, I got that right, Mr. Steve. I know that that is the right answer. And I'll say, why? And you'll say, because I checked it. Because after I got my solution, I checked it and it checked. I know that answer is correct. Okay, so that's the place that we want to get you to. All right, if you're following along in your book, I'm turning over now to the next page, I guess that's 59, sorry. So let's do a couple of these. Let's see what these look like. All right, and I'll keep coming back up to this, and we'll talk about where we are kind of on our list of things to do. 5x minus 3 equals 12. 5x minus 3 equals 12. Now, if you were a good algebra student, if you paid attention in Algebra 1, you should look at that and go, that is the easiest question I've ever seen in my life. Okay? And some of you might be able to do it in your head. It's so easy, and I agree with you. But we need to start here because in Algebra 2, remember, the concepts are not changing in Algebra 2. Here's what's changing. What's changing is the fact that now the questions are going to get a little bit harder than they were. We're just kind of going up in difficulty. Right now we're going to start with an easy one, and we're going to escalate to harder and harder ones as we continue on. Okay, so let's do this one. Let's follow the rules. So we'll go back up here, do what we can do, any like terms. Now, what I mean by that is on each side of the equal sign. So on this side of the equal sign, the left side here, are there any like terms? No. 5x is different than 3. 5x is a variable term, and minus 3 is a constant term, so they're not the same. Over on the other side, there's nothing over there to solve. It's just 12. Okay, so we can move on to step 2. Step 2 is isolate the variable using addition and subtraction. In other words, we want to get x by itself. We want it to say x equals something. That's our goal. That's where we're headed. All right, so let's go ahead and try that. We're going to use the addition and subtraction. So there is a subtraction, and that's what we need to do first. That's what the steps tell us to do first. So we're going to do, instead of minus 3, we're going to do the opposite. We're going to do plus 3. If we do it to the left side, we must also do it to the right side. Why? Because we have to keep that balanced. We've got to keep that equation equal. That's what the equal sign means. And so we're going to add 3 to this side. Well, what's going to happen here is those two things are going to cancel out. We're going to eliminate that negative 3 over there. So we're going to get 5x equals 12 plus 3 is 15. Now there's no more addition and subtraction, so we'll go on to the next step, isolate the variable using multiplication and division. So we're going to go over here and we're going to say, oh look, here's multiplication happening, 5 times x. So I want to eliminate the 5. Remember, I want to get the letters on this side and then the numbers over to this other side. So the way that we do that is we do the opposite. So if we were multiplying by 5, we are going to divide by 5. That is going to cancel, and we're going to get 1x or just x. Okay, so x equals, don't forget, if we did it to one side, we have to do it to the other side. 15 divided by 5 is 3, and that is our answer. Now, we're not done yet, unfortunately. We have to go back and we have to say, oh, there's a step 4. Check the solution. How do you check the solution in algebra? Well, what you do is you take your answer and you plug it back in, you substitute it for the variable in the original problem. So we're going to have 5 times 3. Instead of 5x, 5 times 3 minus 3 equals 12. Now we have to see if this is correct. So we would do this first. Order of operation tells us to do multiplication first. So we'd get 15 minus 3 equals 12. 15 minus 3 is 12 equals 12. And so that is a correct solution. If that was like 10 equals 12, then we knew we had done something wrong. So if that does not come out right, then we know we've got to go back and figure out where we messed up over here to get the wrong answer. All right. And so you might be thinking, wow, that is so easy. Man, I've been doing those for a long time, and that's fine. And a lot of you have been doing those for a long time, and so hopefully they are starting to come easier to you at this point. All right, I'm going to do another one here. This one's going to be a little bit more difficult. 2/3 x minus 4 equals 1/4 x plus 6. Oh, interesting. We've got stuff on both sides here. We've got an x on both sides. So now the first thing that we want to do is do what we can do. If you'll look here, there's nothing that we can do here. Those are not like terms. And then we'll look over here, and there's nothing that we can do over there. So we'll go to step 2, and that is move the letters to one side and move the numbers to the other side. Isolate the variable using addition and subtraction. So I would say let's make this over here the numbers, or let's make this the letters and make this the numbers. It doesn't matter which side you go to, but a lot of times it's easier to put the letter to the left, okay? And so, in other words, what we're going to do is we're going to take this 4 over to the number side. And we're going to take this 1/4 x over to the letter side. That's our goal of this step. So, if I want to get rid of the 4, the negative 4, I would add 4. If I add 4 to one side, I must add 4 to the other side. So that's going to cancel, and I'm going to get 2/3 x on that side equals 1/4 x plus 10. I'm just going to add that together. Now, I still have some more addition and subtraction. And you might say, no, you don't. You're not adding anything else. Yes, I am. Look here. This is actually a plus. I have this over here that I need to move over there. So we are going to subtract 1/4 from both sides, 1/4 x, because we want to move this letter to this side. Okay. So if I subtract 1/4 x from this, that cancels, and I get just equals 10. Over here, I subtract 1/4 x. Now, this is a little bit more challenging, but it's not terrible. In other words, what we have here is we have just fractions to subtract. Now, don't forget, we need a common denominator. So I need this to be a 12, and I need this to be a 12. If you don't know how to do that, I don't have the time to teach it to you in Algebra 2, and I'm sorry. So you need to go back and you need to figure that out. Watch some pre-algebra videos, watch some 5th grade videos, because that's where you figure that out. So if you don't know that yet, you need to go back. So I'm just assuming that you already know how to do that. And so this is going to be 3 times 4 equals 12. So 2 times 4 is 8. So 8/12 is our new one there. And then here, 4 times 3, so 1 times 3. So now we can say 8 minus 3 is 5/12 x. 5/12 x. Okay, so we've done our subtraction. And now there's 2 different ways to look at this. And I'll kind of give you, actually I'm going to kind of show you a couple different things right here. Some of you like to get rid of the denominator here, and so you multiply both sides by 12. And I like that. That works out. Because watch what happens here, 12 over 1. So divide, that gets 1, and so everything cancels, and I have 5x equals, and we'd multiply there, and we'd get 120. And then I can just divide that, divide by 5, and I get x equals, what is that, 24. There we go, x equals 24. Now, let me show you a different way to do that, and you can kind of rewind this and figure out which way that you like to do it best. Let me show you another way that and this is the great thing about math. You can solve these so many different ways as long as you don't break any of the rules. You might look at this and you might say, okay, that's 5/12 times x, and you're right. The way that I did it before was basically that's divided by 12, and I did it that way. But what if you say this is multiplied by that fraction? You're also correct. And so if I divide this by 5/12, this is going to cancel. And I'll show you that right here. 5/12 divided by 5/12. Well, don't forget we have to invert or flip it and multiply. Well, look what happens. Everything cancels out to 1. Okay? So I just did it shortcut right there, and you should remember that from Algebra 1 that we can do that. And so I cancel that side. Well, what do I have to do to this side? I also have to divide it by 5/12. And so I'd have 10 over 1 divided by 5/12, or 10 over 1 times 12 over 5 That cancels to a 1. That cancels to a 2. That equals 24 over 1, or just 24. We got the same answer. We got x equals 24. Okay? X equals 24. So, got a fly bothering me. So you do it either way that you want to there, but you will get the same answer. Okay? You will end up with the same answer. Okay. I think I'm going to do a second lesson on this. There's just too much for me to get into this one lesson. So, all right. That's all I have for you in this lesson. I will see you later. Have a good one. Bye-bye.